Of NASA Science Live. We are so thankful you could join us for this special milestone and take part in another opportunity for you to interact with NASA experts and have your questions answered in real time. I'm your host, Megan Cruz, and today I am so excited to chat with you about Sunday's historic event, NASA's OSIRIS-REX, the first U.S. mission to deliver a pristine sample from an asteroid to Earth. Now, if you have questions throughout today's show, you can send them in using the hashtag AskNASA on social media, or you can drop them into the comment box wherever you're watching. Joining me now are two experts to discuss this incredible mission and explain what's next for the asteroid sample. We have Dr. Dante Loretta. He is OSIRIS-REX's principal investigator from the University of Arizona. And then we also have Dr. Scott Sanford, science lead for the OSIRIS-REX sample return capsule from NASA Ames. Thank you both for being here.
Thank you.
Thanks for us.
All right, so on Sunday, let's recap for everyone. On Sunday at 10:52 a.m. Eastern Time, the OSIRIS-REX capsule you see right there landed in the Utah desert carrying a sample of Bennu, a carbon-rich near-Earth asteroid. You know, I was watching this live broadcast from home. It was so exciting to see that capsule streak across the sky. Then the main parachute opens, bringing it down for that soft landing again that you see right there. Some of the team observing the capsule soon after it came down. Dante and Scott, you know, I know both of you were there for the landing. Describe how you must have felt to be on the ground for that historic moment. I know it must have been really emotional.
Yeah, thanks, Megan. It was the culmination of a 20-year journey for me personally and for this team. And emotions were riding high. You know, as we say, the spacecraft's not just fueled with hydrazine. Our emotions are carrying it through space to that journey to Bennu and back to the Earth. You know, it was full of heart-pounding moments, but when we heard that main chute had deployed and the capsule was coming down for that gentle landing, I literally broke into tears. I was sitting right next to Scott in helicopter 4 on our way out, and I just couldn't hold back. It was just all of the stress and all of the tension just flew out of my body, and I was filled with pride and relief, quite honestly, that we had made it down to the surface of the Earth.
Yeah, Scott, do you have anything to add?
You know, it's going to take me a little while to unpack it all. And the problem is we keep doing things, so I can't catch up. But certainly there was a sense of relief. I let filled with awe to just think about all the places it's been and the things it did. It's just amazing. And just anticipation too, because once the capsule came down, we had Bennu. The day before, we didn't have Bennu. So now there's a whole bunch of things we can do that we couldn't have done before. And so it's just really exciting.
And speaking of exciting, since then, Lockheed Martin, who built the sample return capsule, as well as the spacecraft, has opened that capsule, and we're getting a first look inside. There it is, a picture taken just hours ago. Dante, walk us through what we're looking at right now.
Yeah, this is the scientific treasure box. So what you see is the science canister has been opened up. It's kind of like a clamshell. So the lid is behind us. The white area in the middle is a filter. I think Scott will tell us more about that because that's part of his science investigation. It's on an avionics deck or that aluminum plate. And that air filter looking device right there in the center, that's the touch and go sample acquisition mechanism, or as we call it, the TAG-SAM. That's the device that touched the surface of Bennu, and where we believe inside there is our scientific treasure. So this is our first glimpse of what we might have. There's good indication that we might have sample. You can see some black dust on the deck there. We've got our work to do to figure out really what's going on with all of that material.
I can hear the excitement in your voice, and I know you were excited because we have video of you inside the room when they opened up the canister there. Can we pull up some of that video to take a look at it as well? Kind of walk us through more of the process, Dante, if you can, again, what we're looking at, and just to explain how complicated this all is.
Yeah, so what you saw from the landing was the capsule, which had a heat shield and a back shell, and then this was inside. It's kind of like one of those nested dolls. So you had the heat shield, and then you've got the science canister, and they're pulling the lid off right now. And then sitting inside a capture ring is that TAG-SAM device, and it's kind of clicked in like a ski into a boot into a ski. And of course, I'm thrilled here because this is the moment we've been dreaming of, right? We can see the thing that touched Bennu is now in our laboratories. And of course, we can't wait to get inside. We still got a lot of work to do. We still got to get inside that TAG-SAM. That's where the real treasure is. But We know how to do that, and the team is ready and raring to go.
And for those who don't know, the person cheering in that bunny suit, that was Dante. You explained to me what was happening there. You said that you were texting the picture that you took of the opening of the canister to the rest of the team, right?
Yeah, on the other side of that window that I'm looking to is an observation room. And my mission sample scientist, Harold Connolly, my mission implementation system engineer, Anjani Pollitt, members of the curation team, like Francis McCubbin, the lead astromaterials curator, they're there observing us as we're operating in the clean room. And I'm taking those pictures and then airdropping them over to them so they can get them out to the team to start to process, analyze, and think about what's going to happen next. We have a big important decision ahead of us because we do get to sample some of that dust very quickly, probably tomorrow morning, and that'll go to the science labs here at Johnson Space Center for what we call our quick look analysis. It's a basic assessment. First of all, is that actually part of Bennu, or is it something else, some other dust? Probably Bennu, but of course, as scientists, we've got to confirm, we've got to get the measurements, we've got to verify that that's indeed what we're looking at. So the team is going through those images that I took and making some really important decisions this afternoon.
Yeah, so still quite a process, and we'll go into a little bit of that more in the show. But I do just want to go to Scott right now really quick. So Scott, you're the science lead for the sample return capsule. Talk to us. I mean, did it perform as expected? I mean, it was really amazing hardware to do what it did.
Yeah, the sample return capsule, or SRC as we often call it, was required to do an awful lot of different things for us. And it really performed. I mean, it had to open and close at the right time so as to get the sample tucked away in it. It had to seal tight and keep the sample safe the whole time it was in flight back to the Earth. And then it had to be delivered at just the right place and time in the Earth's atmosphere so that it re-entered and ended up at the recovery site. And then, of course, it had to do the job of protecting the sample from the intense heat that happens when you enter the atmosphere at that high speed. You can see in these pictures the black char that's on the sample return capsule from that heat of entry. And then it had to pop open its parachute, slow itself down to its final velocity, and land. And as you can see, it was we stuck the landing. We came down right on the nose.
Yeah, other than the char that we see obviously on the capsule there, I mean, it really looks almost still perfect, no dings, no scratches, nothing like that.
Yeah, from the marks on the ground, we can tell that it hit almost straight down, but it did a little hop onto its side, and it bounced off its side and rolled back into the original hole. So if it was a gymnast, it would have been a 9.95 because it hit the landing, but it had to make a little hop.
So Scott, now that the sample return capsule is back and there's all the science that has to be done on what's inside, obviously what it brought back, the sample, your job isn't over though, right? Like you still have a lot to go with this mission.
Yeah, for the whole science team, now we get to do the analysis of the samples, which is really key. But for the SRC, we also are doing some things, making measurements and doing analyses to understand how well it performed. And also we can use information from the SRC to inform us about potential contaminants and to make sure we know how to recognize them if we find them in the Bennu sample. And so we'll get some science out of those analyses as well as engineering knowledge.
So Dante, back to you again. Let's talk about that process that you started to talk about. So canister is open, and let's take every opportunity to show that picture of the canister open again. But the canister is open. So now what? When do we get in there to look at the sample and really know what we have?
Right. So when we look at that image, you can see that the tag SAM is still locked into place. And there's an indication that there's a ring of black dust around there. And we're hopeful that that actually is asteroidal material. So what the team is doing right now is I took this image, I took a series of other images, lots of different angles, and they're going to go through and we get to pick an area where we can collect material probably first thing tomorrow morning. And I have what I call my Tiger team standing by. That's a group of scientists, both from NASA, University of Arizona, Purdue University, and they're ready to get this into the laboratories. We're also going to send some out to our colleagues at the Natural History Museum in London because they have some special expertise that we want to take advantage of. And the first question is that actually asteroidal material? Most likely it is, but we have to do that verification. And then we're going to start to test, okay, is Bennu made out of what we think it's made out of based on the remote sensing we did with the spacecraft when we were in the vicinity of the asteroid? And then the curation team's got to go through and they're going to collect all that material, containerize it, get it secured. There's some witness plates on top of TAGSAM and other places around there that recorded the environment that all of that hardware saw when it was in flight. That needs to be secured. And the real moment that we're excited about, and we may get to it this week, and we may not because we're going to go as carefully as we need to, is pulling the TAGSAM off that capture ring, flipping it over onto a stand, and we'll get to see the bottom of it, the part that actually touched the surface of the asteroid. There's contact pads, which are designed to pick up fine-grained material right from the surface. And maybe we'll even get to peek inside. There's that infamous troublemaker rock that propped the flap open right after we collected the sample. I'm looking for that, just to say we got you back on Earth, but also we think it's a really nice large stone, so we're excited to see if it's there. And then we'll move TAGSAM into its own cabinet, and there's an elaborate process to disassemble it, and that might take as much as another week or so before we start to get that bigger material out. So that's the treasure box. That's what we're hoping to have some information, maybe by mid-October, that we can share with our fans and our viewers around the world.
Yeah, obviously, as you said, an elaborate process. So we'll be keeping an eye on everything. And I know that we're hoping, right, to be able to share some information with everybody on October 11th at 11 a.m. Eastern time. Right now, we're inviting people to tune into NASA's YouTube and social media channels to see the actual sample and discover what researchers like Dante and Scott have discovered so far. So again, set your calendars, your phones. I know I have. Okay.
Yeah, we're optimistic we'll have something to say by then, Megan. We'll have something really interesting by October 11th. We're optimistic we'll be able to share some really great news on that by that time.
That's exciting. Okay, so the question on some people's minds might be why this particular asteroid? What do we hope to specifically learn from Bennu? If Dante, you want to start.
Yeah, Bennu's a very special kind of asteroid. It's dark, and we think that means it's loaded with a very important chemical element, carbon. Carbon is the central element to all life on Earth. And you got to remember, Bennu and the minerals that it's comprised of formed over 4.5 billion years ago at the dawn of our solar system. And it represents the kinds of objects that we think brought the water that's in our oceans, the molecules that's in our atmosphere, and maybe even the organic material that led to the origin of life on our planet. So we're going back to the distant past to try to understand and address the big question, where did we come from? And maybe if we can figure that out, we can start to say, are we alone in the universe? So we picked Bennu because of this really interesting composition, and we can't wait to get in and verify. That black dust that we saw on the deck there surrounding TAGSAM gives me some hope, because one thing carbon does is it makes things very dark and very black. So immediately we have a good sign that we might have actually brought that kind of material back from this asteroid.
And Dante, Bennu was also chosen too, right, for the study of planetary defense.
Yeah, that's actually a great part of our mission. So we had to pick an asteroid that was easy to get to after you launched off the Earth, rendezvous with, and get back. And because of that orbital dynamics, that means Bennu comes very close to the Earth. And in fact, in the future, may come uncomfortably close to the planet. It is a potentially hazardous asteroid with a small but non-negligible chance of impacting the Earth about 160 years from now. So I don't want people to worry too much about this happening soon, but this is an important insurance policy for this particular asteroid. But I think more importantly, we have developed the technologies now to get out to one of these objects, characterize its physical and chemical properties, and plot its future trajectory hundreds of years into the future. So in the event that we have to deal with any incoming asteroid, the information and the knowledge that we gain from OSIRIS-REX will be invaluable to those future activities.
Scott, how long have you been a part of this mission, and how does it feel like today after all that time?
Well, let's see, Dante's had been almost 20 years now, I guess, since the very first time we started to suggest to NASA that this would be a good thing to do. So, yeah, it seems kind of like a lifetime.
Just about.
So, yes, Dante, he alluded to it, that you've been with this project for 20 years. How do you feel?
Yeah, we first conceived of this idea in 2004, February, so almost 20 years ago now. And it is a lifetime pursuit, right? I mean, we dedicated our careers to making this mission succeed. And it was all driven by what we were about to embark on, which is sample analysis, right? So in 2004, we were like, wow, wouldn't it be great if we could have a fresh sample of carbon-rich asteroid in our laboratories to address these outstanding questions that we can't answer any other way? And persistence, patience, plenty of heart-pounding moments, including the ones that we had on Sunday. Later, here we are, mission success. We have brought this capsule to Johnson Space Center. We've opened it up, and we've just got a few stages to go before we can really declare that we have done everything that we've promised this agency we would do.
Great. And if I haven't said it, congratulations to you guys on all this so far.
Thank you.
Now we have lots of questions coming in from viewers watching online. So remember, you can submit those questions using hashtag #AskNASA or posting that in the comments section wherever you're watching today. Okay. So our first question is from General Space 3 on Instagram, asking, what's the significance of having this asteroid sample? Will it help with space exploration?
That's a great question. Yes, absolutely. There's many aspects to the OSIRIS-REX science investigation. We already talked about the origins, the fact that Bennu is a treasure trove from the dawn of the solar system. And we talked about the security investigation, Bennu being a potentially hazardous asteroid, and our ability now improved to predict its future trajectory. But another part is resource identification. Bennu is an accessible object. As these things go, it's relatively low energy to rendezvous with, and now we've proven to bring material back to the Earth. One element or compound that we think is particularly abundant on this asteroid is water. And water you can process into liquid hydrogen and liquid oxygen. That's one of the most powerful rocket fuels that we know of. So I love to think about in the future, people will be taking the information we collected from OSIRIS-REX, using it to design these asteroid mining missions, and building these fuel depots in space to further exploration to the surface of the moon, to Mars, and beyond.
Really, it's enabling even more science than maybe you guys had even thought of when you first created this idea.
Absolutely.
All right, and we have another question here. Actually, many of our viewers are asking a very similar question. What happens to the OSIRIS-REX spacecraft itself? Does it burn up in the atmosphere?
Well, the good news is the answer is no, it will not burn up in the atmosphere, because right after we released that sample return capsule, we fired our rocket engines and moved away from the intercept trajectory with our planet that we were on. And the name changed. It is no longer OSIRIS-REX. It is now OSIRIS-APEX. It is on a journey to another very important near-Earth asteroid named Apophis. And I'm really proud of the legacy. Apophis is a fascinating object. It's about 300 meters across, so a little smaller than Bennu. But in 2029, it's going to come within 20,000 miles of the surface of the Earth. That's closer than our weather satellites orbit right now. So it's the biggest, closest approach of an asteroid for 1,000 years. And I'm passing the torch. The new principal investigator is now Professor Daniela Della Testina from the University of Arizona. She's taking the reins. It's her spacecraft and her team. They're going to lead this next journey to Apophis.
Scott, you might want to take this next question. So this is from Facebook. During entry, did the intense temperature of the capsule have any effect on the sample?
So yeah, this is one of the important things the capsule does, is it kind of acts, so when we get a meteorite, it enters the atmosphere, and a large part of the meteorite is basically vaporized and is lost. So rather than us losing our sample this way, the heat shield on the SRC actually does the ablating. And so as you generate heat, it's carried away as this gas. You see this trail behind in the image here. This is the heat of deceleration going away. And so the heat, a lot of the heat doesn't penetrate into the middle of the SRC because the hot material is swept away before it can conduct any heat inside. So the analysis that's been done suggests that even though the outside in this plasma can be 5,000 degrees or so, the inside of the capsule is not expected to get above about 50 degrees C. So this heat shield protects our sample from that very severe environment and just sweeps it away.
Yeah, that's so impressive. Hackman617 on YouTube asks, what are some of the things that this asteroid sample will tell us about how our solar system formed? Will the importance of this mission be understood by future generations?
Excellent question. Absolutely. So as I mentioned before, we're looking at ancient material, older than any rock on Earth, even older than our planet itself. And we're really interested in the water, which probably formed as icy material out in the outer solar system when we were still a protoplanetary disk. When planetary systems are forming, these giant molecular clouds collapse, you form a star, and then the material that's left over creates a disk. And inside that disk, you have all this fascinating chemistry taking place. So we're looking at how did water get into the solid material? What happened when that ice got into an asteroidal-sized object? It probably got nice and hot and melted and formed a fluid and altered the minerals that were originally present. So we really want to understand protoplanetary disk and asteroid geological processes to figure out how these minerals and chemistry changes and ultimately how they get delivered to the inner solar system to make Earth a habitable world.
I really am interested in this question. On Instagram, what was the biggest challenge for this project? Or maybe you personally, I think either of you can answer that question as well.
Scott, you want to start?
I'm trying to think what's biggest. There were a lot of challenges, so but the team worked their way through all of them. I mean, it certainly one of the challenges was Bennu didn't get our proposal in advance. You look at some of the artist conceptions of what the tag was supposed to look like, and the pictures of the asteroid show it looking like a kind of gentle beach of sand. And we got there, and it was this gigantic jumble of boulders. And so we really had to back up and figure out where are we going to get this sample from.
Yeah, and I would say personally, right? It's we say space flight is long periods of boredom punctuated by moments of extreme terror. And so you've got to learn to keep your cool when things are really happening and the moments are arising. And the thing that has got us through all of that is teamwork, right? This is an amazing team. It's University of Arizona, Lockheed